Good morning. This is our first lesson on what's called composition of functions. It's a little bit weird for me doing this lesson. This is actually the last lesson that I did last year before everything went on lockdown and we didn't go back to face-to-face instruction. So it's a little bit weird. It's like I've come full circle. So by the time I get to inverses, which is the next lesson, I'll have, I might actually have some lessons on inverses already done. Who knows? I'll have to go and take a look. But we're going to cover composition of functions. I'm going to basically work through a couple of examples and then we'll see how far we get, and we might do one of those lessons where we do all the instruction in one video and then the next class is all practice and there's not like another lesson or video for the second class. We just need to practice what we did in the class before. So I've already kind of addressed composition before, and this came up when we were doing multiplication of functions, and I gave you that little composition, the little hiccupy stub your toe spot where I said when you're doing multiplication you have to do that nice big dark circle, closed circle, and I emphasized that in class that it had to be a closed circle because the open circle actually means something else. And now we get to that something else. The notation for composition is this, and it's like your f of g of x. So how you read that out loud is f of g of x. And what it means, here's our meaning, is this. You would take f and then you would plug g into f. And so composition is essentially this. It's when you plug one function into another function. That's what composition is. Now, let alone like why would we ever want to do it? And I actually like my dual enrollment example better than I like the example that's in the notes for this particular class. So I might actually change direction. In fact, I think I did that last year too, because I kind of remember coming into my classroom and there were still like pictures of boats on my whiteboard. Is kind of eerie and creepy, but so that's the meaning of it. Now, as with anything, if you don't like the of x, you can just write this. Now, just so you know, that looks like the word fog, which is that white stuff in the air sometimes when we come to school in the morning and it's like really humid, it's like super foggy, and it looks like fog. And if you do it the other direction, it looks like goth, which isn't a word. Now, fog and goth are not official math words for talking about composition. This is composition of functions, and the way you say that is f of g or g of f is how you would say that out loud. But in our everyday language, when we're talking to each other, you're talking to a math teacher, you go to your tutor, and your tutor says, "What are you doing in math class?" If you were to say, "We're doing fog and goth," your tutor will know what you're talking about, even though that's not like a real precise math word, because it looks like fog and goth. And so we actually do say that sometimes. I just want to be clear that you know that that's not actually the right word. It is composition of functions, and it means f of g or g of f of x. Now, when it comes to doing composition, when I first learned how to do this, I had a terrible time with it because fog means this. It means f of g of x. So you're going to take g and plug it into f. If you have g of f, it means you take f and you plug it into g. And I could not keep them straight. Like, I just couldn't remember, do I take the first one and plug it into the second one, or do I take the second one and plug it into the first one? Really, really bothered me. Obviously, I got over it, but it really bothered me. So when I teach this, I'm going to give you some steps that will help you not be confused about it the way that I was confused about it. So we're going to go through a couple of examples. Actually, just like one example, we're going to work it two different ways. So we're going to do f of x is equal to, what is f of x equal to? X squared, there we go, minus 2x plus 3, I'm missing a part of the x there, and g of x is equal to x plus 1. Okay. Now, what I'm going to do is I'm going to do the process, except I'm not going to have enough space here. Hang on. All right, that looks a little bit better. On the left-hand side, I am going to give you 3 steps, and then I'm going to do an example on the right-hand side so that you can see what the steps look like, and I will try to color code it. I'm actually going to do some extra work just for the point of like the purpose of color coding it, and the color coding is to help you see the steps a little bit better in what I'm actually trying to do. So for your first step, we'll do this in purple. The first step is to simply copy the first function. So over here, if we are doing f of g, when I say copy the first function, what I mean is copy function f, just function f. So this is different than the other types of operations that we do where we might have like f and g, and then we have a plus sign or a minus sign or a divided or whatever. You put both f and g out there. When you're doing composition, you are going to start with just writing one of the functions, not both of them. Okay, and that's how I can tell on homework and stuff who's paying attention, who's writing stuff down, because if you start writing down F and G together in the first step, then I know you're not listening to what I'm saying. So copy just the first function down. Now, what I'm going to do in this second step here is all I'm going to do is rewrite, and I'm going to use a color to just highlight the X's. That's all I'm doing there. So I didn't really do anything in that step algebraically. I just like swapped out the color. And the reason I'm swapping out the color is because for step 2, we are going to plug in the second function everywhere there's an X. So plug in the second function for every X. So if you only have one X, you only have to plug it in once. If you have more than one X, you have to plug it in more than once. And so this function, G, is going to go in every place I have an X. So instead of X squared, it is going to be X plus 1 squared. And instead of 2X, it is going to be 2X plus 1. And so what I'm doing there with the color is I'm just trying to make it visually pop out to you a bit more like what you did there. Now, at that point, the composition is actually done. Remember that composition is plugging one function into another function. So once you've plugged one function into another function, you're technically done with the composition part of it. And the rest of the problem is just simplification. And so step 3 is simplify. Simplifying can be really simple, like 1 or 2 steps, or simplifying can be really, really messy. So when you get into like harder versions of this, you might be plugging yucky fractions into yucky fractions. And you want to make sure that you know, like, there's different skills there. There's the composition, which is just the plugging in, versus the simplification, which is where if you're like weak on your fractions, that might trip you up. So for the simplification process, remember that when you square a binomial, that means you multiply it by itself. Okay, so you have to FOIL that together. You cannot just say x squared plus 1 squared. It would be nice, but it's wrong. So I'm going to FOIL this, so I have x squared plus 1x plus 1x plus 1. And then I'll distribute on the second one, so minus 2x squared minus 2. And then we're just going to combine our like terms. So we've done this before. We have an x squared. Then I have like a bunch of x's. So I have plus 1, and then a minus 2. Well, 1 plus 1 is 2x, and then 2x minus 2x is 0x. And then, so all of that dropped out. What color haven't I used? So like those all canceled out. And then for my constants, I have 1 minus 2. Actually, it's easier to do it this way. 1 plus 3 is 4, and then do 4 minus 2 is 2. And we're done. There's your composition. Ta-da! So hopefully, like, you were able to follow that. That's about as difficult as I expect, like a standard algebra 2 class to get, is like plugging a linear into a quadratic. They do get much uglier than that. So my, dual enrollment kids will sometimes have to plug like like functions into fractional functions. And, we might do a couple of other composition ones in this class that are a little bit trickier, but mostly, like when you're first learning composition, the goal is to learn the concept. You guys know I'm really big on the concept. If you understand the concept, which is plugging one function into another, and you have a set of steps that can help you make sense of it that are generic steps, like they'll work for any kind of function, those steps will work. And then practice with the simple problems. And then if you do see a more complicated problem, you know that the concept hasn't changed at all. All right. So what we're going to do is do the other direction. All right. So I just copied those, the functions over again. And this time we're going to do g of f. Okay. So we're just switching the order around. We do want to notice a couple things about this. So the way your notes should work is your notes should be like, first of all, you should be taking notes. Okay. Don't rely, like, just because I do notes and I save them on Teams, like notes in Teams doesn't necessarily help you if you don't go and look for them. So, you want to look back at your notes, and after your moment of panic saying, oh, this composition thing, I hate that. Then you would say, okay, what did she tell us to do? So Miss Taylor told us copy the first function. So in this case, the first function is g, and I'll try to keep my colors consistent. So in this case, we're going to start with x plus 1. There's no f in the problem in that first line. Just copy the first function. Now, because I am still modeling this for you, I will go and highlight that x in red. That is just for teaching. You're not going to do a separate step where you highlight it, unless you want to, if you got like one of those pens that has a million colors to it. Now, the next step, plug the second function in for every x. And so my second function in this case is the f. It's like whichever one is second. And fortunately, I only have one x there for plugging it in. So that's kind of nice. And then we simplify. And so I'm just going to do, I've just removed my parentheses there. And all I can really do to simplify that is do 3 plus 1. So there you go. 3 plus 1 is 4. Now, I want you to notice a couple of things about this. First of all, notice that fog, we got x squared plus 2. And goff, we got x squared minus 2x plus 4. So I want you to notice this. I want you to notice that fog does not equal goff. At least not all the time, once in a while. The technical term for that is, we would say, composition is not commutative. So that's the property that governs whether or not you can switch the order of things. So adding is commutative. Subtracting is not commutative. Okay, so those, and so what we know about this is we know that composition is not commutative. Now, that's not to say that they're never the same. It says that they don't have to be the same. It's not a property. The other thing I want you to notice is that often, you wouldn't know it's often, you just know it happened once. I'm telling you it's often. One direction is easier than the other. And so as you're doing like some practice problems, you might notice, you'll notice that goff there was a much simpler process than fog. It just had less in the way of simplification. So that can happen a lot of times too. And if I'm trying to write a test or something, then what I'll probably do is I'll give you the easier one, because on a test, I'm trying to assess whether you get the concept. On a homework, I might give you something more challenging, because homework is not high stakes, and it's a great time to kind of push the limits of how hard, you can go, and can you like reason your way and think your way through other problems, but or like more challenging problems. But on a test, we usually try to keep it to like, do you get the concept? Now, sometimes you'll see a variation on this, and your book, for those of you that have a copy of the book, will will show like this like kind of weird variation, and there's a complicated way and like an easy way to do it. So I'm gonna show you the easy way to do it. The way this works is that they'll show it to you like this: f of g of like 9. Okay. So I'll let you write it down, and I'll let you kind of look at it for a second and see if something stands out to you. Like, oh, look at that. Like I have an idea, because you should have an idea. Like it's f of g of 9. So ponder it for a moment. And if with my face-to-face class, we might take, a moment and just kind of see what kind of ideas people have. But what you could do is think, here's the idea that we're going to employ. You're going to work from the inside out. And so the inside there is g of 9. Well, all that means, like g of 9 means you plug in a 9 for the x. And so g of 9 is 2. And so f of g of 9 is just a fancy way of saying f of 2, because g of 9 is 2. And so f of 2 would just be 2 squared. And so the answer to the problem is 4. Now, there are other ways you can do that, and there are a couple other ways that the question could be asked. So you guys know we're doing the EOC review problems, and sometimes you'll see a problem and you'll know that we've covered it, like a translation or something. You'll know that we've covered the content, but the way the question looks is just different. So like other ways you might see something like this is you might see like fog of 9. Okay, like you could see it that way. And it would be the same concept, just written a different way. All right, so that's how that works. So I'm going to put some practice problems, and then we'll call it a day for that. And then the second lesson on composition, we'll just talk about an application problem. So let's go ahead and put some practice problems up. Okay, so there are essentially 4 practice problems here. Practice is fun and stress-free. And think of it that way. Practice, like when we do a problem like this is your chance to kind of find out if you're going to make mistakes, but there's like literally nothing bad that can happen to you if you make a mistake. So your practice, like your in-class practice, is a opportunity for you to like try out the concept and just see what happens when there's literally nothing bad that can happen to your grade if you get it wrong. If you get it right, you're going to feel great about yourself. And if you get it wrong, you get this like free opportunity to kind of say, well, what did I do? What did I misunderstand? Like, and fix it before you have to do something where there are points at stake. So for the first one, we have 2 linear equations, 3x minus 4 and negative 2x minus 1. When they're both linear, it's not going to be bad. The composition isn't going to be bad at all. So you're going to do fog and golf, do the composition in both directions. For the second one, we're keeping the same functions that I used in the example. So f of x is equal to x squared and g of x is x minus 7. Now, where I did f of g of 9, you're going to do f of g of 7. So that should be just kind of duplicating the work that I did, just with a different number. Hint is Miss Taylor's favorite number. And then for the second one, you're going to switch the order. You're going to do g of f of 4. So you're going to start with the f of 4, start on the inside, and then work your way out. And we'll see how that goes. Next lesson is going to be super short, and we'll get additional practice after you guys have a chance to look at your homework. Okay, for those of you following along at home for the joy of it, so let's go ahead and go over the practice problem. So the first practice problem, when we have fog, we're going to start with function f. You start with that first function. So 3x minus 4, and then you're going to plug the second function into the first function. So where I have the x, I'm going to take out the x, and I'm going to plug in g, which in this case is 2x minus 1. And then we'll simplify to get negative 6x minus 3 minus 4, and then negative 6x minus 7. Going the other direction, we start with just function g, and then I take out that x, and I'm going to plug in function f, which is 3x minus 4, and then we'll get negative 6x plus 8 minus 1, and a positive 8 minus 1 is positive 7. Notice that they're not the same. They're close, they're similar, but they're not the same. So that's how the composition should have worked. And that's like a good, like that just really tests like whether you get the concept of doing the composition. And really the only thing anybody can do is just give you yuckier functions where maybe you have more substitutions to do and the simplification is harder, but nobody can really make the concept any harder than that. Like that's the concept. All right, for the second one, we were doing f of g of 7. And so you're going to start with the inside with g of 7, which in this case would be 7 minus 7. And 7 minus 7 is 0, Miss Taylor's favorite number. So f of g of 7 is just a fancy way of saying f of 0. And so in this case, that would be 0 squared, and f of 0 is 0, and your answer is 0. There we go. And then the last one was g of f of 4. So remember, the concept stays consistent. Math is consistent. So when I give you the concept, which is start from the inside out, you're still going to start from the inside out. Okay, just don't let other stuff mess you up. So we're going to start with f of 4, which in this case would be 4 squared. So f of 4 is equal to 16. So g of f of 4 is just a fancy way of saying g of 16. Well, g of 16 would be 16 minus 7, which is 9. So our answer to that is 9. And hopefully that went well and you feel pretty solid with it. And we'll get some additional practice next class.